So here's the first lesson for Chapter 5. Chapter 5 is all about linear relations, and our first lesson is for Section 5.1, direct variation. So in this lesson, what you're hopefully going to learn how to do is you're going to learn what a direct variation is, and you're also going to learn the importance of a rate of change in a direct variation relationship. And we're first off going to start by discovering what a direct variation relationship is by looking at some tables of values and looking at the rates of change of the variables. So, let's start with this example here. Example 1, use a table to organize information in the following problem. How long does it take to fill a 3,000 liter hot tub if a water truck supplies water at a rate of 250 liters per hour and the tub is initially empty? So, let's start off by looking at what key pieces of information are given to us in this problem. So we want to fill a 3,000 liter hot tub. So we know it can hold 3,000 liters of water. We know that the water truck supplies the water at a rate of 250 liters per hour. And we know that the tub is initially empty. So I want to complete this table of values with all of that given information and figure out how long it takes to fill this 3,000 liter hot tub. So first of all, I know that the tub is initially empty. It starts off empty. So if we've been filling the tub for 0 hours, so before we even start filling it, how much water is in the tub? If it's initially empty, there are 0 liters of water in the tub. Now, you'll notice in the next row here, for time, it says 1 hour. So if it's been being filled up for 1 hour, how many liters of water in the tub? Well, it says it supplies the water rate of 250 liters per hour. So after 1 hour, it will have 250 liters of water. And then after 2 hours, so after another hour passes, it's going to get another 250 liters per hour because it supplies this water at a constant rate of 250 liters per hour. So after another hour passes, it'll have another 250 liters added in, so it'll now be at 500 liters. And then it'll keep adding 250 liters every hour. So let's complete our table. 1250, 1500, I'm halfway there. 1750, 2000, 2250, almost done. 2500, 2750, and finally I've filled the tub with 3,000 liters of water. So the question asks us how long does it take to fill a 3,000 liter hot tub. So I'll look at my table of values. It had 3,000 liters of water in it after how many hours? 12. Okay, so my answer to the question would be it would take 12 hours to fill the hot tub. Okay, so that's my answer to that part of the question. Part B, what if the truck was to double the flow rate? So up here, it supplied the water rate of 250 liters per hour. What's double 250? 500. So it's saying what if the flow rate is 500 liters per hour. So don't forget the tub's initially empty. So it starts off empty, and then it's now supplying it at 500 liters per hour. So after 1 hour, it'll be at 500. After another hour, it'll have another 500 in there, so it'll now be at 1,000. Then 1,500, then 2,000, then 2,500, then 3,000. Okay, so what if the water truck was to double the flow rate? Well, it would take half the amount of time. It would only take 6 hours. So it would take 6 hours to fill the tub with 3,000 liters of water. So the next part of the question says, which of these variables is the dependent variable? We're going to have to remember the difference between a dependent variable and an independent variable in this unit. Okay, so look at the table of values to see your two variables. I've got time in hours and water in liters. So those are my two variables, time and amount of water. So which one of those is dependent and which one is independent? So what I do to figure it out, okay, to determine the dependent variable, ask yourself the following key questions. Think, does the amount of water depend upon the time, or does the time depend upon the amount of water. And the correct answer here is the amount of water in the tub depends on how long you've been filling it for. So the amount of water depends upon the time. So that means the amount of water is dependent and the time is independent. Okay, so I'll just label my table here. So time, I've decided, is independent. And in most cases, when you're doing a question with two variables, if time is one of the variables, time is usually the independent variable. That's why it's in the left-hand column, because we always put the independent variable in the left-hand column, and we use the letter X to represent the independent variable. Water is in the right-hand column, because water is the dependent variable, and the dependent variable is always in the right-hand column, and we use the letter Y to represent the dependent variable. Water depends upon time. And we're going to look more closely at this relationship between these two variables, and we're going to see why this is a direct variation relationship. So, before we can make the connection, we have to look at what a rate of change is. So in this case, if I can ever get the page to go to the right spot, okay. In this case, if we want to calculate the rate of change of the water in the hot tub as time goes, the rate of change is equal to the change in the amount of water divided by the change in time. That's what this little triangle here means. It means change in. So change in water divided by change in time. That'll give us the rate of change. That'll give us the liters per hour. And why do we do change in water divided by change in time? Well, rate of change is always the change in the dependent variable over the change in the independent variable. Remember, dependent is y, independent is x. We always want to do change in dependent divided by change in independent. And in this case, remember, water is dependent on time. Water is the y, time is the x. So that's what we're doing. We're doing change in dependent divided by change in independent. And we'll get our rate of change. And rate of change is very important when dealing with linear relationships. So let's look at the rate of change of water going into the tub between 0 hours and 1 hour. Let's do it for the first part of this question here, when it's going in at 250 liters per hour. So let's look at that. So we want to figure out the change in y divided by the change in x. So between 0 and 1 hours, what's the change in y? What's the change in the liters? Well, it goes from 0 to 250 when the time goes from 0 to 1. So let's set that up as our ratio here. So we have rate equals change in y over change in x. So it goes from 0 to 250. So to figure out the difference, just 250 minus 0. And between 0 and 1 hours, so the change in time here, 1 minus 0. So I got 250 divided by 1, which equals 250 liters per hour. So if I'm just looking at these two data points between 0 and 1 hours, if I calculate the rate at which the water is going into the tub, it's going in at 250 liters per hour. Now let's look at what rate the water is going into the tub if we look at the time between 0 and 2 hours. So we're going to look at what's the change in water divided by the change in time. What's the rate for change in water divided by change in time from 0 to 2 hours? So from 0 to 2 hours, it goes from 0 to 500 liters. So what's our change in water over our change in time? Well, it goes from, so it starts at 0 and goes to 500, so calculate that difference, is 500 minus 0. And the change in time from 0 to 2 hours, calculate that difference, 2 minus 0. That gives me 500 over 2, which is equal to 250 liters per hour once again. Now, maybe this is a coincidence that these two are the exact same. Let's take a look at what the rate of change is between 2 hours and 5 hours for the amount of water compared to the change in time. So let's go back up and look at our table of values. So between 2 hours and 5 hours, it went from 500 to 1250. So our change in water, it went from 500 to 1250, so calculate that difference. So 1250 minus 500. And between 2 hours and 5 hours, calculate that difference, 5 minus 2. That gives me 750 over 3, which equals 250 liters per hour. And you'll notice, once again, that rate of change of the amount of water in the hot tub is constant. It's the exact same for all three of these. Okay, so what do you notice about these rates? They are all the same. They are all the same. So the water is going into this tub at the exact same rate the entire time. Okay? It doesn't change at all throughout any of these. If you calculate the difference between any of the time frames, so if you look at the difference between 8 hours and 12 hours, it went from 2,000 to 3,000. So that's 1,000 liters in 4 hours. If we do change in y divided by change in x, 1,000 divided by 4 gives you 250 once again, because it goes in at 250 liters every hour, same rate the whole time. That's why this increases by 250 every single time. It's a constant rate of change. And what we actually call that value, okay, when the rate is constant, it is often referred to as the constant of variation. So this 250 here is the constant of variation for that relationship. Before we move on, I just want to quickly make sure you're able to tell the difference between the dependent variable and the independent variable. That way when you're calculating your rates of change, you're doing it in the proper way. You're doing change in the dependent divided by change in independent. You have to make sure you're doing that the proper way, because if you do reverse that by accident, you're going to get the wrong constant of variation. So let's look at this. A car travels at 75 kilometers per hour. We've got two variables, kilometers and hours. And if you remember what I said, if you have a unit of time, hours, it's most likely the independent variable, okay? Because the hours doesn't depend on the kilometers. The kilometers that you drive depends on the time, okay? So it traveled at 75 kilometers per hour. So in order to figure out how far someone has driven, if you know they're traveling at 75 kilometers per hour, you need to know how long they've been driving for, okay? Because the kilometers depends on the hours. So the dependent variable, kilometers, the independent variable, hours. In November, the temperature drops 1.2 degrees Celsius per day. Once again, we've got two variables, degrees Celsius and days. Days is a unit of time, and like I've told you, time is always going to be your independent variable. So days. And our other variable, degrees Celsius is our dependent variable. So the temperature drops by 1.2 degrees Celsius per day. So the temperature depends on what day it is, okay? Degrees Celsius depends upon the day. Okay. So let's look at example 3. Each set of data represents a direct variation. Okay, now I'm actually going to give you the definition of what a direct variation is. A direct variation is a relationship between two variables in which one variable is a constant multiple of the other. Okay, so it has a constant rate of change. And let's look back at our table of values from the previous one. We've got our two variables. Oops, too far. Too far again. Alright, there we go. We've got our two variables, time and water, x and y. The definition of a direct variation is that one variable is a constant multiple of the other variable. And if you look at this, y is a constant multiple of x. To get the value of y, all we have to do is multiply x by our constant of variation. And if you remember, we calculated our constant of variation was 250. Constant of variation is 250. So to get the value of y, we just have to multiply x by that constant of variation, 250. So look, if I multiply x by 250, so multiply this value of 2 by 250, I get 500. 4 times 250 is 1,000. 8 times 250, 2,000. And so on. That's how y is determined for each of these, because y is a constant multiple of x. And that's true for any direct variation. You just need to know that constant of variation. Okay? So one variable is a constant multiple of the other, and to determine the value of y, you just multiply x by that constant of variation. Alright, so let's do a little bit of work with direct variation relationships. So determine the constant of variation, rates of change, given the data in the following table. So remember, the constant of variation is whatever that rate of change is between the two variables. Remember, in a direct variation, the rate of change is constant. Okay, it's the same the whole time. That's why it's called a constant of variation. So now we're going to look at our table of values and calculate our rate of change, or our constant of variation. Okay, and remember, the constant of variation, or the rate of change, is the change in the dependent, so the y, divided by the change in the independent, x. And remember, in a table of values, the left-hand column is always x, the right-hand column is y. So that's why I have this here. Okay, so my two variables are hours worked and money made for part A. So dependent variable money made, that depends upon the hours worked, and that makes sense. Okay, the amount you make depends upon how long you work for. That makes perfect sense. So let's calculate our rate of change, or our constant of variation, by doing the change in. Remember that triangle means change in. So the change in y divided by the change in x. And if you remember, a direct variation has a constant rate of change the whole time. So you can choose any two data points to calculate your rate of change for this. I'm just going to try and keep it simple by choosing the first two data points. So I'm going to find the difference in y. So the difference between the first two data points, 35 minus 0, divided by the change in x. So if I use the first two data points for y, I have to use the first two for x as well to get the right constant of variation. So the difference between 0 and 1 minus 0, that is 35 over 1, which equals 35. So my constant of variation, or rate of change, for the relationship between money made and hours worked is 35. Okay, so I'm actually making $35 per hour. Not bad. Alright, let's look at B. Mass of grain is my one variable, cost is the other. So this tells me, since cost is in the right-hand column, I know that's the dependent variable, so cost depends upon the mass of grain. So I can calculate the rate of change between these two variables by doing the change in y divided by change in x. So change in cost divided by the change in the mass of the grain. And that'll tell me the cost per kilograms of grain, or per kilogram, sorry, of grain. So let's calculate that. And I'll use the first two data points here as well. So I'm going to calculate my change in y. So 125 minus 0. And then I'm going to calculate my change in x. So I use the first two for the y, so I also have to use the first two for x. So 20 minus 0. So the change in y was 125 minus 0, which is 125. And my change in x was 20 minus 0, which is 20. Okay, so if I do 125 minus 125 divided by 20, 125 divided by 20, okay, I get 6.25. So that means it's $6.25, okay, or $6.25 per kilogram. So it's $6.25 per kilogram of grain. Okay. So what is the same in the relationship given in parts A and part B? So let's carefully look at these table of values. Let me get rid of all this excess stuff so we can view it easier. Alright, so I've got rid of all that excess. What's the same between these two tables of values? Well, really the only thing that's the same between these two, if you look carefully, is the initial values of both of them. In this table of values, the initial value of x is 0, the initial value of y is 0. In this one, the initial value of x is 0, initial value of y is 0. Okay? So they have the exact same initial values. Okay, they have the exact same initial value of 0, 0. What's the same in the relationship between part A and part B? They both have an initial value of 0, 0. And I just summed that up right here. A direct variation will always have 0, 0 as the initial value. Always, always, always. So if you see a table of values with 0, 0 at the top, and it has a constant rate of change, it's a direct variation relationship. Okay. So I just want to solidify this a little bit more. Let me just show you that it doesn't matter which two data points you choose to calculate your rate of change. So let me just get rid of this, and let's calculate our rate of change using two different data points. just to show you that it's going to be the same for all of them. Okay, so let's say I wanted to do calculate the rate of change using the first and the third data point. So I'm going to calculate the difference between the first and the third. So that's 70 minus 0, and I'll have to do the first and the third for the x's as well. So that's 2 minus 0 to get the difference there. So now I need to do change in y over change in x to get my constant of variation. And I get 70 over 2, which is 35. So once again, I got 35 as my constant of variation. And if it is a true direct variation relationship, it doesn't matter which two data points you choose, you'll always get the exact same constant of variation. That's why it's called a constant of variation, because it's a constant rate of change. Okay, now let's learn how to write the equation of a constant of variation. And if you remember when I told you the definition of a direct variation relationship, where did it go? It is a relationship between variables in which one variable is a constant multiple of the other. That's why the equation of a direct variation relationship is y equals mx, because y is equal to the constant of variation m times the independent variable. Just like I showed you, I'll show you it here as well, okay? So we're going to call our constant of variation, we're going to use the letter m to represent the constant of variation, okay? And I've just told you the equation of a direct variation is y equals mx. So to calculate y, all you do is multiply x by your constant of variation. So multiply x, so multiply 2, let's do it for 2. Multiply 2 by the constant of variation, 2 times 35, that will give you y. That's why y is equal to mx. Multiply 3, if we multiply 3 by our constant of variation, 3 times 35, that will give you 105. That's because y is equal to m, 35, times x, 3. Hence the equation y equals mx. So let's write an equation for part A. Our constant of variation is 35. So our equation is y equals 35 times x, because y is a constant multiple of x. And for part B, our constant of variation was 6.25. So y equals 6.25 times x, because y is a constant multiple of x. And then let's just quickly make sure we know the difference between independent and dependent variables one more time. So for both of these, we'll do a and b again. Which is the independent variable for A? Remember, independent variable is always on the left, so hours worked, and for B, mass of grain. So A, hours, B, mass. And which is the dependent variable? Dependent variable is the y value. Dependent variable is always on the right. So for A, it was money made, and for B, it was cost. So for both of them, we were talking about money. Okay. So in general, the equation of a direct variation has the following properties. So this is what we've learned so far. We said the equation of a direct variation is always in the form of y equals mx, okay, because y is a constant multiple of x, where m, the letter m here, represents that constant of variation, that constant rate of change. So now let's look at, we're going to move into learning how to graph a direct variation now, okay? So example 4, the cost to do electrical work varies directly with time. That's a key sentence right there. So it's given you a lot of information just in that first sentence. The cost to do electrical work varies directly with time. So right off the bat, it's told you that varies directly. It's told you that this is a direct variation relationship. It tells you that one variable is a constant multiple of the other. And it'll actually tell you which one is the dependent, which one's the independent, just in this sentence. It says the cost to do work, so cost, there's one variable, varies directly with time. Another way to think of this word varies directly, you can think of that as, that means depends upon. So cost depends upon time. That means cost is your dependent, we use y for dependent, and time is your independent. And remember, like I said before, time is always going to be your independent variable. Okay? So that first sentence has given us a lot of information. Okay? So let's keep reading. Electric company charges $25 per hour. $25 per hour. So it's given us a rate of change right there. It's given us our constant of variation for that company. And then it gives us another company, while AC/DC Electrical charges $50 per hour. There's another rate of change. So it's given us two rates of change for two different companies. So $25 per hour for our electric company, $50 per hour for AC/DC Electrical. So it's given us two different companies. They each have their own equation. Okay, so let's write an equation for each of them, and remember the equation has to be, for a direct variation, is y equals mx. M represents that constant of variation, or that rate of change. And in the question, it gives us that rate of change, $25 per hour for electric company. So that means that our m value, I'll just write it in the margin here, m equals 25. So that means the equation is y equals 25x. And for AC/DC Electrical, the rate of change was $50 per hour. So that means our rate of change was 50. That means the equation is y equals 50 times x. Okay? Because y is a constant multiple of x. To figure out what the cost is, you multiply the time by 50. So let's use this equation to complete the table for 0 to 4 hours for both companies. So I know to calculate, so first of all, let me label my table of values with x and y. I know independent is x, it's on the left, dependent is on the right, and I use y for dependent. Now I know that for electric company, y is equal to 25 times x. Cost is a constant multiple of hours. So I know it's going to increase by 25 every single hour. So first of all, what's 0 times 25? 0. What's 1 times 25? 25. 2 times 25 is 50, and then it just keeps going up by 25 each time. Okay? That's because the constant of variation is 25. Now, the other table values, this time our constant of variation is 50, so it's going to go up by 50 every hour. Cost depends upon time, and to calculate the cost, we multiply time by 50 because it's $50 per hour. So for 0 hours, it's $0. 0 times 50 is 0. 1 times 50 is 50. 2 times 50 is 100. And then it keeps going up by 50 because that is our constant of variation. It goes up by 50 every hour. Now let's graph this data. So these are all of our points here. So they both have an initial value of 0, 0. Both of them start at 0, 0, and that's the definition of a direct variation. They both start at 0, 0. So let's graph electric company first. So after 1 hour, or for 1 hour of work, it costs $25. So for 1 hour, it costs $25. So I'll plot that point here. For 2 hours, it costs $50. For 3 hours, it costs $75. And for 4, it costs $100. And then I'm going to connect to those with a straight line. I don't want to move the point. Let's see if I can try this again. Maybe I'll just do it freehand. So this should be a straight line that I'm about to draw. Hopefully I can figure this out pretty soon. I'm going to start down here. Okay, I'm going to start down there. That'll let me do it. Okay, so connect those with a straight line. And there's the graph for the cost of the electric company. Now let's do the cost of AC/DC Electrical. If I look at my table of values, remember it goes up by 50 for each hour. So it starts off at $0 for 0 hours. And after 1 hour, it costs $50. 2 hours cost $100. And then it keeps going up by 50 every hour because 50 is the constant of variation. Connect those with a straight line, and then I will have the graph. This is going to be tricky. I'm going to have to start this one lower. And there we go. There's the graph of that one. So maybe I can fix this up. Get it starting right at the origin. Good. Let's do this one too. Good. Okay, so you'll notice how both of the graphs are straight lines. Okay, that's important. That means that it has a constant rate of change. And both of these graphs start right here at the origin. They both start at 0, 0. That's important for a direct variation. It has to be a straight line that starts at the origin. So let's answer a couple questions looking at this graph. So looking at the graph or the table, which company should I choose if I have a job that requires 3 hours of electrical work? So if you need some repairs in your house with your electrical system, and you know it's going to take 3 hours for them to repair it, you're going to want to choose the company that costs less. So look at your graph here at 3 hours. Okay, which of these two graphs is going to have a lower cost? Well, this graph right here has a lower cost at 3 hours. I should have labeled these graphs so you know which one is which. This one was the electrical company. And this one was AC/DC. So at 3 hours, electrical company has a lower cost. Okay, it costs $75, while AC/DC costs $150. So we're going to choose electrical company to do the job that takes 3 hours of work. So we'll choose electric company. Okay, how can we show the rate of change on the graph? Or another way I'd like to ask is, how does the steepness of the line relate to the rate of change? So that's the important thing I want you to notice here. How does the steepness of this line relate to the rate of change? Well, we know the rate of change for electrical company. We know the rate of change, or the constant of variation, was 25. And we know for AC/DC, the rate of change, or constant of variation, was 50. So AC/DC has a steeper line because it goes up by 50 every time. Okay, so what you want to notice here, the steeper the line is, the higher the rate of change. Electrical company isn't as steep because it only goes up by 25 each hour, so it's not as steep. So a higher rate of change means a steeper line. So I'll just jot that here. Steeper line equals higher rate of change. Remember, your rate of change is your constant of variation in a direct variation relationship. Okay, what is the same for both graphs? I already discussed this. Both graphs are straight lines that pass through the origin. Remember, the origin is point 0, 0. So those are the two things that are the same for all direct variation relationships. Their graphs are straight lines that pass through the origin. Okay, now let's do some word problems. We're almost done. So we're going to have to be able to calculate a constant of variation from the sentence it gives me. In order to do that, I'm going to have to be able to determine which one is my dependent variable, which one is my independent variable. Because remember, the constant of variation, m, is equal to the change in y over the change in x. So let's look at this. Distance traveled by me when I drive varies directly with time. So I've given you the fact that it's a direct variation relationship. Varies directly. And that means, remember, you can think of that as saying depends upon. So my distance traveled depends upon time. That's what varies directly with time means. So my two variables are distance and time. Remember, time is always going to be your independent variable, and distance traveled, that's me my dependent variable. Time independent, distance dependent. X always goes with the independent, y always goes with the dependent. And that's because the distance I travel depends upon how long I've been driving for. Okay? Y depends upon x. Y varies directly with x. My car travels at 630 kilometers in 3 hours. So it gives me my change in distance and my change in time. So it gives me my change in distance, my change in y, and it gives me my change in x. It's 3 hours. So what is my constant of variation? It's my change in y over change in x, so 630 divided by 3. And that gives me 210, okay, kilometers per hour. That's my rate of change. Don't forget your units. 630 kilometers divided by 3 hours. That's why I get kilometers per hour. Write an equation to represent the relationship between the variables. So remember, the equation is always going to be in the form y equals mx for a direct variation relationship. I've just calculated my value of m. It's 210, so just plug that into your equation. And I get the equation y equals 210x. Which variable is dependent? Which one's independent? Well, we already discussed that. Our dependent was distance, and my independent was time. Distance traveled depends upon the time. Alright, next example, same type as the previous example. The total cost varies directly with the number of MP3s downloaded. So once again, it'll tell you in the question that it's a direct variation by telling you this. It varies directly. That means direct variation. And that also means that the cost depends upon the number of MP3s downloaded. So those are my two variables, cost and number of MP3s downloaded. Those are my two variables. And I know cost varies directly with number of MP3s downloaded, so that means cost depends upon that. So cost is dependent, it's y, and number of MP3s downloaded is independent, it's x. So the cost depends on how many I download, and that makes sense. Okay, and then it'll give you your change in y and your change in x. So remember, MP3s is your x, so it gives me 13 MP3s. Okay, so that's my change in x, and my cost, it gives me my change in y, is 1287 for 13 MP3s. So what is the constant of variation? Remember, constant of variation is your change in y over your change in x. So that is 1287 divided by 13, and that gives you 99 cents per MP3 you download. Okay, so that's the rate of change. That's your constant of variation at 0.99. So if we want to write an equation, remember your equation is y equals mx. I've calculated the m value. I've calculated my constant of variation. It's 99 cents per MP3 we download. So the cost equals 99 cents times the number of MP3s I download. Which variable is dependent, which one's independent? Once again, we've already discussed that. Our dependent is cost, and our independent, the x, is MP3s downloaded. Okay, so let's just quickly consolidate everything we've done. So direct variation occurs when the dependent variable is a constant multiple or I'll say this in a different way here, sorry. Varies by the same factor. I like to say it better the way we've been saying it all along, is a constant multiple. When the dependent variable is a constant multiple of the independent variable. Another way of saying that, the way this is laid out here, varies by the same factor. Varies by the same factor as the independent variable. I like to say it the other way though, like they mean the same thing, but I like to say the dependent variable is a constant multiple of the independent variable, and that means that they vary by the same factor. Okay? A direct variation can be defined algebraically as, we know the equation is y equals mx, and we know that y is the dependent variable, x is the independent variable, and m is our constant of variation. M is the constant of variation. And we calculate that by figuring out the change in the dependent variable divided by the change in the independent variable. And the graph of a direct variation is a straight line that passes through the origin, so it'll always look something like this, a straight line that goes right through the origin right there at 0, 0. Okay. And that's it for a direct variation. Remember, calculate rate of change in dependent divided by change in independent. Remember, that's what that little triangle stands for. That means change in. Okay, change in dependent y over change in independent x. Okay, and that's it for that lesson. Sorry that one was a little bit longer. Make sure you let me know if you have any questions.